Good day, students. Today, we want to solve problems that involve displacement. You must understand what displacement is. Displacement is, is the distance traveled in a specified direction. Okay? Again, displacement is the distance traveled in a specified direction. When you say the man moves 2 meters due north, because of that due north is now a displacement and not a distance. When you say a man moves 2 meters, that is a distance. Okay? Now, the question we want to solve now, you have to read it carefully. Physics is all about reading the question carefully to know what they are trying to say. As if a man walks 10 meters east, our cardinal point, we have north, east, west, south. You must always take your reading from the north if you want to know the direction. Like this. If you are given this angle, let me say 30 degrees, for example, here to the east, to this horizontal line, to know the direction of movement, you always take your reading from the north. You know that this is a right angle triangle and you are given 30. When you want to get the direction, you say 90 minus 30, the remaining will be 60 degrees. When you are now saying it, now be north 60 degree east, because north comes before east. You can't say east 60 degree north, no, north 60 degree east. That's the direction. Okay, now let's see what's here. If a man walks 10 meters east, this is your east. The man now walk 10 meters east, 10 meters east, and 10 root 3 meters northward. This is your north, this is your east. Now then you continue and this is north, 10 root 3 meters northward. What is displacement? Displacement is this, which is the resultant. What is displacement? This is displacement. It's a vector quantity because it has direction. When you solve the problem and you get your displacement, you have to get the direction because displacement goes with direction. It's the distance traveled in a specified direction. Okay, now let's call this one A, small letter A is B. Okay, and this is a right angle triangle. Don't forget that this also the north. What I'm saying is that when you get this angle, let's call this angle alpha, you must get this angle. This is real direction you are going to get. You remove it from 90, this 90, remove from 90 to get the direction. But you must get the alpha first. Now, what you need to do is to use Pythagoras theorem, but this is a right angle triangle using Pythagoras theorem. Now, s squared, because our displacement is s, equals to a squared plus b squared. The square of the longest side equals to the sum of the two other sides. Don't forget, this is our opposite to this angle. Opposite, this is our adjacent. So our adjacent. This is our hypotenuse. Hypotenuse. Okay. Now, don't forget your SOHCAHTOA. SOHCAHTOA. Since we know this opposite, we know the opposite and the adjacent, I'm going to use tan. tan alpha. Tan alpha equals opposite over adjacent. You know this sine theta or sine alpha equals opposite over hypotenuse, cos alpha equals adjacent over hypotenuse, tan alpha equals opposite over adjacent. Okay, you want to get your direction. Let's finish that of displacement. S squared equals, what's our A? 10 squared is 10 plus 10 root 3 squared, which is equal to 10 squared plus 10 root 3 multiply, you are multiplying it twice, 10 root 3 times 10 root 3. S squared equals 10 squared is 100 plus 10 times 10, that's 100 times root 9. Root 3 times root 3, that's root 9, equals 100 plus 100 times root 9, which is 3. Root 9 is 3. S squared equals 100 plus 100 times 3, that's 300. You have to multiply this first before adding. But if you add before multiplying, it will not give you the same thing. That's why you have to follow board mass. Board mass multiplication before addition. Let's do the addition. You see that it's different. 10 plus 10, that is 200 times 3. That's 600, you see, which is wrong. Now let's do this. Let's follow the normal way. 100 times 3, that's 300 plus 100 plus addition before multiplication before addition. I see 400. This is the correct one. Now, which is equals to 400 Now S squared equals 400. Find the square root of both sides. These two cancel this square root. Your S now equals square root of 400 is 20 meters. If your S now is 20 meters. Okay. Now let's look for the direction, because displacement goes with direction. This is your displacement, but it has to go with direction because it's a vector quantity. Distance moved in a specified direction. Okay, now let's get our tan alpha. Tan alpha plus what's our opposite? Opposite over adjacent, which is equal to what our opposite, as 10 root 3 over adjacent 10. 10 cancel 10. Tan alpha equals root 3. Because what's our root 3? Root 3 is 1.7321. 1.7321. His displacement won't be complete without stating his direction. Displacement must go with direction. Is that okay? Now, his displacement now, before getting displacement now, we have gotten displacement for the direction. This is what we are trying to look for. Now, tan alpha equals 1.7321. Alpha equals tan inverse of 1.7321. When you are pressing your calculator, second function tan, press the second function and press tan to give you tan inverse. Alpha now is 60 degree. Some students make mistake by putting this 60 degree as your direction, which is very wrong. This alpha now is 60 degree or you now subtract it from 90, the total. Okay, total now, let's call it theta. Total this is theta. No, it's 90. Now this side we are looking for is theta. The theta now, which is direction equals 90 minus 60 degree, which is 30 degree. Now when you are telling us the direction of it, you say north 30 degree east. Now is displacement is 20 meter north first before east, north 30 degree east. That is displacement. Direction must follow the displacement. This is the end of our class. Please subscribe to my channel so that you can have access to the latest video. Have a wonderful day.